This is Electric Universe Geology Earth News. The image you're looking at is the Cascades. It's northern Washington state, just south of the Canadian border. Here's Highway 20. It's the North Cascade Highway, runs through it. A friend of mine, Mel Atchison, went camping somewhere around here. I'm not exactly sure where it was. And he was sort of up at the top of one of these ridges and looked down into the valley and noticed that there was a stream. And on either side of the stream, there was a mountain with zero sediment. None whatsoever. Just a stream. Not one single bit of sediment. And supposedly these mountains have been here as long as all the other mountains. So if it was the standard geological model, this should have enough time to have all of the little pieces of rock that are the mountain erode. One little grain of dust at a time, filling in the canyons. But they're not. They're empty. And this is really different than a lot of other places. And I think I know the reason why. Let me zoom out. You'll see this canyon right here has a lot of sediment. There's flat stuff down here, as opposed to this and all these other places. So what we have, if you zoom out, we have, here's Princeton, let's see, here's, I'm looking for Lake Okanagan. Let me zoom out a little bit more. Oh, here, Penticton. Here's Lake Okanagan. This is kind of a low point. If there was a rush of water from the equator, as Velikovsky proposed, because of a reversal of rotation, which is what I see in the field, the water would have been constricted by this area, but not held in completely. It could get north. It could go past this. It's not a bathtub, as it were, like other areas, which are completely enclosed by a drainage system that has passes that go up to 9,500 to 10,000 feet. So this water can get north. It was able to push into these canyons, but it wasn't able to get to the top. And what's interesting is the detail of these mountains. They're incredibly detailed. The ridges are so distinct. You can see every little ridge. It's really something, the detail involved here. Again, I'll have a link to this and other things at the bottom of the video. But as you go east, this detail starts to get smudged out. The lighter green seems to be slosh that was pushed in, had enough energy to get this far, but not that far. So the light green seems to be a marker. And here you can see all the details completely smudged out as you get closer to where the water was rushing north and pushing right east and west, but not enough force to really get it up there. Now, the Colorado River is a completely different story. That has 9,500 foot passes. Let's go look at that, the headwaters of the Colorado. Here we have the headwaters of the Colorado River. This is Kremling. The river runs through this canyon, which I think was prevented, not eroded, by the way. The train comes through here, the main line between Chicago, I think, and San Francisco. And then the river runs through here, and then up by Rocky Mountain National Park, and down through here, south of Granby. There's a town here called Fraser. I spent a summer here. And this whole valley is completely full of sediment, and it goes up really high. Now, these smooth areas might be windward, so it might be smooth because it's windward, not because it's sediment. But if we zoom in here to Fraser, Joe Fraser, which is where I stayed, it was really interesting, you can see the valley's completely sloshed in. It goes up really high, all the way up to here where you start to get details of the mountains. This seems to be slosh, and it filled it in. It starts here. This is the drainage down here. This is a river that runs through here. There's another one over here. But it was all filled in with sediment, very deep, because there was nowhere for this water to go. And the water brought sediment with it, and it rushed north in a closed system with very high passes, filling in this valley with sediment. The return flood seems to have carved this channel out. So you have these really distinct ridges cut into the sediment, which I think is the water rushing back to the equator, tearing out the side here. This is where the water current got strong enough to remove that. By the way, this river runs right through this mountain, which is really cool. Again, I don't think it eroded it. And then if we come over here to let me get my bearings here real quick, zoom out. Ah yes, here we are, Silverthorne. Nothing but shopping discount centers. It's horrible, little town with nothing but malls. There's nothing. It's a brand new town because they built a dam and they moved stuff. So anyway, this is also connected to the Colorado River. This river runs north into the Colorado, believe it or not, up to Kremling, and then it goes to the west. So here we have this other valley here, and it too is filled with sediment all the way up to this mountain. That's how closed in this drainage was. You can see there's sediment up here. I lived up here at Wilderness. There's a point where it gets flat and there's road cuts, and you can see that it's underwater sediment. And then again, all of these rivers are going to drain to the north. As the water gets lower than the sediment, it's going to rip out the channel, just like it did in Fraser. So these canyons are full of sediment because it's a closed system. The more closed the system, the greater the pressure. As this area is filling up with water and it can't get out, and it's going up to 9,500 feet, the basin, the bathtub as I like to refer to it, is going to fill up, and it's going to force the water to go back down where it came from. The height of the water would rise downstream as the bathtub fills up. The water might be able to get over some of the 9,500 foot passes. And there could be water coming in from different directions, because this was pretty messy. There were sloshes in different directions. This is a little sidebar. In Worlds in Collision, during the Hebrew version of the plagues of Egypt, in between the passage from the Red Sea and the law giving at Mount Sinai, which is about 3 months according to Velikovsky, the sun changes its motion 4 times. Not a reversal, but it changes its motion, which means the sun stays stable, but the earth is changing its motion, in addition to a reversal. So now you have a flood going north, filling in these basins. At the same time, the earth is being sloshed around. Each change of motion would cause a slosh in the opposite direction. So it's kind of complicated. Here you can see the colors again. You can see the detail up here in the mountain where it's not sloshed. I don't know why Google Maps changes the color, but it almost seems as if they're trying to help us see the sediment slosh area, as opposed to an area where you can see the ridges cleanly because they weren't coated with sediment. So this is my story on the flood of Exodus, or the plagues of Egypt, or the worldwide plague of darkness, as opposed to the flood of Noah. The flood of Noah, according to Genesis, was 19 feet high. It was a certain number of cubits, and it reached to the top of the mountains. That implies that the flood was fairly minimal and the mountains were really tiny during the flood of Noah. But it's not as if it's reaching up to the top of Everest. It's 19 feet according to the height in cubits. So this is a different flood, a different animal. It's not just ocean level rising. It's sloshing and water from the equator and then going back to the equator. It's much more complicated. Sorry this was a longer video, but it's a lot of material. Thank you.